Imam MA. So he will be talking on treatment of landfill leachate. Professor Sabir Imam, I think, yes. Can you hear me, Professor Sabir Imam?
Sir, can you able to hear me?
Yes, I can hear. Yes, yes.
Yeah.
Yes. Okay, so our next session will be from Professor Sadi Imam, and its topic is on treatment of landfill leachate. So I will introduce him. Professor Shabi Imam is working as a head environmental wing at Germany, that is Gujarat Environmental Research and Management Institute, and also associate professor at Pandit Dindayal Energy University. He is a Schedule 1 environmental auditor. Earlier, he worked as assistant professor at AIKTC, Panvel, and research associate at IIT Bombay. Dr. Shabi Imam was selected as prestigious Erasmus Fellow Award by European Commission all over Asia, and he served 1 year as international research scholar in Marleden University, Sweden. Dr. Shabi Imam has 27 publications in various international journals and conferences. He presented research paper in various international conferences and also got excellence paper award at conference held at Hong Kong. Dr. Shabi Imam is also reviewer of various international journals, and he has attended many induction training program. He has given lectures, and he is selected as one of the 120 candidates selected across India, where 4,800 teachers are shortlisted for a ICT-based learning program. So, and recently he has been appointed as the member of the EIA committee for process change. So, I invite Professor Sabi Imam to give a lecture on the sanitary landfill. Welcome, Professor.
Thank you very much, Dr. Sanjay sir. So I would like to thank you all the participants and the management and the HOD of the Civil Engineering Department. So today I would like to share my experience on landfill leachate treatment. Everyone able to see the slide? Just confirm it once. Just.
Yes. Sure.
Yes. Yeah. So these are the outline of the slide. So, sir, am I audible?
Yes, you are audible. Yes.
Yeah, because I feel pin drop side. No. So you are aware of that what is landfills as an environmental engineer? We were aware of that landfill is the place where we used to dump our waste after the usage. So urban population in India was less than 10% in 1947. It was grow up to 27.8% in 2001. India is witnessing a rapid urbanization according to the census 2011. Indian urban population was 37.7 crores, which is projected to grow about 60 crores by 2030. Now it is around 40 crores. Already we have reached 43 crores around. So due to rapid population increase and lifestyle, the solid waste generation increase. And it is reported that 90% of the municipal solid waste is disposed in open dumps, landfills unscientifically created problems to the public health and the environment. So now we see. So I have actually basically I will discuss about the what are the treatment opportunities available to treat the landfill leachates, and we will see one of the study we have conducted in Mumbai, Devanar landfill. So how the leachate was significantly treated, what are the problems we faced during the treatment of leachate. So you aware of that most of the like big cities like Mumbai, Delhi, they are already overloaded with the waste. That year also already expired. The dumping years supposed to be 8 years ago. The landfill supposed to be closed. Still we are running due to unavoidable conditions. You can see the Deonar is one of the largest landfill in, you can tell, second day in Asia. So it generates 7,826 tons per day waste. Okay, now we are aware of that what is municipal solid waste. So basically whatever our household waste we are using along with our vegetables, paper, glasses, these are and all what we are doing after the usage we are sending into the landfill or any other. Recently we are doing the treatment technologies like composting, or we are doing some kind of a recycle process like pyrolysis, we are doing incineration. However, comparatively landfilling is more to other techniques because not available the technique and cost of the technique and efficiency of the techniques. So the landfill leachate generation is unavoidable. So landfill leachate is formed when the water enters to the waste in the landfill cell in the form of rain, inflated snow, melt. As the liquid moves through the landfill, many organic and inorganic common compounds and heavy metals are taken and transported with the leachate. So what will happen? Whatever the waste we dumped in the landfill along with the water, it generates a complex organic and inorganic liquid that is called as a landfill leachate. It is highly viscous aqueous solution containing high concentration of inorganic and organic pollutants, usually accumulated near the bottom of the landfill. So these are the few photographs we taken. So when we visited the landfill height was 7 storage yard building. So it's like 11 floor building size, the landfill sizes. It was 110 hectare plains. Although modern landfills are highly engineered landfill designed to eliminate or minimize the adverse impact of waste, the generation of leachate is still a major problem. Municipal solid waste landfills, because the leachates may be pose a significant threat to the soil, surface water and groundwater. You can see wherever the open dumping is there, you can easily find the groundwater contamination is there. However, we can put our clay layer, synthetic layer, artificial layer to create a new engineered landfill. In here goes the future filtration or infiltration is possible and overrun is possible due to monsoon, and improper design also may give a significant leachate generation. So number of landfills in India in 2019 by state wise we can see Madhya Pradesh have a 378 landfills, Maharashtra have 320 landfills, and again it is keep on increasing. It is including not only a scientific landfill, it is also including the open dumping yards. So major objective of our study was we were thinking to collect the leachate from the landfill, actual landfill. So treat the leachate using various techniques like using chemical and biological treatment technologies. Initially, we collected the landfill leachate at various seasons like summer, monsoon, winter, and we analyzed the characteristics of the landfill leachate because we cannot go in a direct scheme technology to treat the landfills until we understand the characteristics. Second, the leachate pretreatment in terms of COD and TOC removal and color and turbidity from using various coagulation techniques like chemical techniques. Again, we use the pretreatment as an oxidation process like hydrogen dioxide, phentan, photophentan, and ultraviolet radiation with hydrogen peroxide and ozonation. To study various combination of chemical processes like coagulation followed by photophentan, UvH2O2, ozonation, and catalytic ozonation. To study, so we have tried all the combination of treatment, so which can give you a proper disposal limit according to you aware of the discharge limit of CPCB. You have to reach your COD less than 250 and BOD maybe 30. So we need to achieve this to dispose into the natural water stream. So what is the characteristics of leachate? Leachate is a leader among to hard to treat wastewater as it shows a complex structure and unprecedented challenges in the age of the landfill. So what happened? Leachate have various mixes like we are throwing a organic waste, inorganic waste. It is having a heavy metal content. Sometimes pharmaceuticals will be problem. So whatever the waste we are dumping into the landfill, it converted into leachate that will be in the bottom. So main issues what happen if you are not doing a proper leachate collection and treatment system. If you are not doing a proper leachate collection system, there will be a possibility of landfill blast, because over methane production or methane production, improper methane production. So what will happen? It's got on fire. So you may be aware of that. In 2015, that Mumbai got a Devna landfill got a fire. In 2017, in Ahmedabad, Prana had a fire. It may be one of the reasons because the proper leachate treatment may not be done due to the improper management. So the possibility of methane gas exploration. So leachate can be cause contamination of soil, aquifers, and surface water and groundwaters when it contact with this. Removal of COD and BOD and ammonium from the leachate usual prerequisite before final discharge into the natural water. The need for a proper treatment of leachate from the landfills of various ages form the basis of the present research. So we can see a country-wise landfill leachate characteristics. So these are some examples from Reno et al. And Lima et al. You can see the COD and BOD by COD ratio, pH, suspended solid amount. You can see most of the leachate contain the BOD by COD ratio is 0.6 above, 0.5 above, and pH is around alkaline range. And you can, so from this what we can find, the leachate usually vary the characteristics based on the age. The age is one of the important parameter to treat the landfill leachate. So the age is less than 5 years. These landfills are called as a young landfills. So what happened when we started dumping into the waste to the landfill, which contain a high amount of readily biodegradable compounds like high BOD, high COD. That's why the BOD by COD ratio is always more than 0.3 or 0.5, however. So these are the leachates usually within the 5 years. So the leachate can be easily treated by using a biological treatment techniques. So next, medium age landfill leachate is nothing but this is 5 to 10 years. It usually having a little alkaline range like 6.5 to 7.5. The CODs ranges from 3,000 to 15,000, and BOD by COD ratio is 0.1 to 0.3. So why we are always mentioning the BOD by COD ratio? You are aware of that biodegradability is a matter when we choose for the biological treatment process. When leachate get more older, the COD get reduced. So like it's become 2000 milligram per liter, but we can happy with that because what will happen? The whatever the readily available organic matters will be consumed by the microbes. So the whatever remaining is the COD is a non-biodegradable COD, which also contain a high value of recalcitrant. This leachate is very, very difficult to treat because, and again, what are the factors may affect the quality and quantity of the leachate? So many factors will affect the generation of leachate. You are aware of that leachate is one kind of a hard to treat wastewater. So waste composition, whatever the waste, you may be seeing the waste composition in India, waste composition in Asia, waste composition in Europe is entirely different. Why it is different? Because we use more, we generate more food waste and we throw it in the bin. But in other developed countries like US, UK, these and they used to throw the food waste in a separate bin. It will go into the composting process. Whatever material, and they have a very high segregation policies, like they have a 9-bin system, 7-bin system. So what will happen? The 7-bin system, even the milk pouch they're buying, like a Tetra Pak we buy in India, in some companies we buy a milk, there is a open, there you found an aluminium foil over there. So what we used to throw, we throw the aluminium foil as well as the pouch in the same bin in our waste. So they have 9-bin system, they throw the aluminium foil in the separate bin, the Tetra will be the separate bin. So when I visited Sweden, I was there for a year. So there is one option is there for you. So you are in a hurry to go your office, or you don't know where you need to put, there is option called rest of all. There is a 7 bin will be there. So apart from the 7 waste bin, you will have the 8 bin is called rest of all. So you can keep it in the bin. The waste collection employee from the municipality will come and he will segregate on his own. So that's why waste will be segregated in a high way. So that the waste composition is not so difficult. So the waste is dumped in the landfill is highly degradable, and their dumping rate also very reduced. They're dumping only 2% of the waste generated through there. So here we are dumping 91%, they're dumping 2% of the waste. So again, this waste composition will vary, is not only vary with the country to country, it will also vary with the season to season. Like festival season is the, like we are using Diwali, Christmas, and various festivals. So we generate like Diwali, we generate more waste, and the waste composition also significantly vary. This also affect the quality of the generation of leachate and the depth of the waste. Of course, depth of the more depth is there, penetration will be more infiltration will be there, and moisture availability. And when I was talking about the age, so I'd like to go back. So when you're talking about the age of the landfill, the landfill will be stabilized at the year of more than 10 years. It will get stabilized and we will get a continuous leachate generation over there. But one thing, usually the young age, the landfill leachate is more acidogenic because the acidogenic reaction takes place. After that, the medium phase, you will get a methogenic phase. The methogenic bacteria will survive. The most of the time, the open dump yards will be condition of thermophilic. That's why it's getting more hot. And again, in the old age, most of the microbial activity will be get stopped. So there will be present a little microorganism, and we have only recalcitrant and very complex compound to degrade. So again, availability of oxygen is need to degrade the waste and produce, and the age of the landfill. Already I talked about the age of the landfill. Apart from the main factors affecting the quality quantity of leachate, again a precipitation, the rainfall also affect, and the evaporation, transportation, and surface runoff, groundwater infiltration, contact with the water, and degree of compaction. You may be aware of that. Whatever the waste we generated. So nowadays, what we used to do, we used to collect the waste from the houses, and we will transfer into the compaction truck. The compaction truck will go to the transfer station. They will remove the young fresh liquid, whichever possibility by the compaction. The remaining will go to the dumping yard. This will always reduce the quantity generation of the landfill leachate. So now we will go to the main area. What are the treatment techniques available to treat the landfill leachate? So the first technique is nothing but a recirculation of leachate within the landfill and combined with the sewer treatment and biological treatment and other treatment. So we will see one by one. The recirculation of leachate. What is meant by recirculation of leachate is nothing but the recycling of the leachate to maintain the moisture content in the landfill and improves the stabilization time and the quality. When we maintain certain moisture condition, so it will attain fast stabilization stage. So for that we need to maintain a moisture content. So we used to recycle the leachate in the same landfill. The sponsor et al. Has shown that 92% of CO2 removed in influent condition of leachate temperature in 21 liter per day. He has conducted the study of recirculation, and he has to be able to remove that 92%. And of course, it is a young leachate, you can tell. And combined, whenever we are going to the recirculation of old leachate, it is not possible because it has contained already recalcitrant and undesirable organic compounds. So we cannot recirculate into there. It will disturb the stabilization of the landfill. So next, combined treatment with sewage. The disposal of treatment of untreated landfill leachate could be done by diverting towards the sewage treatment, wastewater treatment, in one of the simplest method of that. So most of the cities, I aware of that in Mumbai, there's a Cooper wastewater treatment plant is there near. They used to earlier they used to collect the leachate from the landfill through through the tankers, they will go and dump into the sewage treatment plant. But according to the new rules, it is not possible. We cannot directly dump into the sewage treatment, the landfill leachate into the sewage treatment plant, because it's not only the COD, BOD, it is also the one of the major issues again heavy metals. So this will go to the biological treatment which already explodes, like municipal solid waste treatments. You are aware of most of them are biological treatment techniques. When we get into the system, it will simply kill the microbes. The entire system will get collapsed. So they are avoiding. However, the addition of untreated leachate increase the organic loading as well as nitrogen concentration in the sewage. This sudden increase of organic load affect the regular sewage treatment process. This is applicable only for the untreated leachate. If the treated leachate is there, that is applicable to, you can discharge into the land, or you can discharge into the wastewater treatment plant according to the state authority or central government pollution control board. And biological treatment. Biological treatment, basically, you are aware of that there is a two biological treatment is there. One is an aerobic treatment, another one is an anaerobic treatment. So in aerobic treatment, we have a suspended growth process as well as we have attached growth process. In suspended growth process, the media, the bacteria or the fungal, whatever we are using, that used to suspend in the system, then we get treated the water like aerated lagoon, sequence batch reactor and activated sludge process. So we'll see one by one. So aerator lagoon process. An aerator lagoon process is holding and treatment provided. It's nothing but your pond will be used with the surface aerators. So it will give the oxygen to that. It is a simple technique. It is usually used for your wastewater, like your sewage water or grey water. As simple as effective and low cost approach, aerator lagoons are used to on-site treatment landfill leachate, in which treatment occurs via biological oxidation. To meet strict environmental regulations, that's what I told, aerator lagoon may not be completely satisfactorily obtained. That means what happened when we treat, we may not able to attain the disposal limit of the landfill leachate. That means the landfill leachate may not able to treat it completely. The partial treatment is possible. As well as this landfill leachate contain toxicity, heavy metals, it will affect the soil. So if we mention the temperature difference of lagoon, so we can go activated sludge process. You are aware of activated sludge process, the mixture of organisms cultured in a reactor which can consume organic matter. It's nothing but it will consume the organic matters, it will convert that your organic carbon into CO2 plus water and minerals. The activated sludge process is widely used for treatment of municipal water or co-treatment of landfill leachate. The next is sequencing batch reactor. The steps in sequencing batch reactor, few people told it is a 4, few people tell it is a 5. So it is nothing but it is first initial step is it is nothing but a similar activated sludge process running in a batch mode. But we can make the sequence batch reactor in a continuous mode also. Like if you are having a cycle, like 8 hour cycle you have, you can have a 3 separate batch reactor which can fix the continuous cycle. You have a 6-hour cycle, you can build a 4 tank reactor, so that can make the continuous system. Like fill the wastewater and react with supplying the oxygen aeration, and after aeration complete, it will settle, the treated supernatant will be collected to the draw mechanism or decan. So they will tell this decan and draw idle, this will become a single process. So Doyle et al. Conduct a study hydrate nitrification of SBR mature leachate obtained from domestic leachate. The leachate possess high ammonia content with an average concentration of 88 mg per liter, while average BOD, COD was around 60 and 1100 mg per respectively. After nitrification of 5 days HRT, leachate was charged to sewer for nitrogen process. Similar nectar also done the study. The 99% of the ammonium nitrogen is removal using aerobic treatment leachate. So at attached growth process, we have again a trickling filter. It consists of highly permeable media, a water distribution, its attaching system. And here interestingly we see few of the aerobic process performed in the leachate and how they got. Actually like Jalam and et al, they have studied that the leachate. You can see here, you can notify the significance thing is that all the biological treatment you can see here, like you can see the most of the places the BODB by COD ratio is more than 0.4 or 0.5. You can see because these are the leachate which is readily available. It's a fresh leachate, we can tell it is a young leachate. This can be directly treated by any biological treatment process. But however, we supposed to know the limit and discharge and how it is efficient. Again, they have conducted study with like COD 80 milligram per liter, again pH 8, BOD base. There is a volume of reactor is 16,500 liter and trickling filter and 87% of BOD. You can see here most of the cases, this is a biological reactors. They have like 16,500 milligram per liter, 80,000 is removed, even 90,000 is become 1650. It is again a discharge issues will come. The next is MBBR. Similar like anaerobic process. Anaerobic process like UASB process basically combine well mixed attribute contact system with the internal gas. So here you will get another advantage of getting a methane gas. And these are the various performance of the anaerobic reactors. You can see there. So here they treated anaerobically like using your anaerobic SBR or USB process and HBR systems. Now we will go to the next treatment technology. It's a physical chemical treatment. So physical chemical treatments, you are aware of that. Usually we are using some physical forces or chemical components. Like evaporation, evaporation can be defined as a natural evaporation or artificial evaporation. Natural evaporation takes place to the open pond system. So we can sun-based evaporation, and another artificial evaporation takes place like ME, like multiple effect evaporators again. So Ranji et al has investigated the evaporation of natural and artificial waste on average and achieved by 33% evaporation by artificial methods. And again the problem concerned with the evaporation of raw leachate is formation of foam due to high organic content and fouling of heat transfer surface because it contains a lot of TDS, and again need the post treatment for removal of ammonium and halogenated organic materials. And of course heating energy with using evaporation is a high energy cost. Next very interesting classical treatment technology is a coagulation process. It's a chemical process. You are aware of that coagulation techniques, nothing but we are adding a coagulants. It will neutralize the pollutants. It will make it settle. Like stabilization, destabilization and restabilization. Hello? Sorry. So coagulation, flocculation, you are aware of that. It is a chemical based water treatment. They usually used for the wastewater treatment and water treatment. So this technique consists of following: the use of chemical reaction destabilize to increase the size of the particles. Like flux will form, the physical separation we give a mixing, then it will get settled down. Coagulation for mainly used for treating a stabilized taste leachate mostly. Whatever treatment technology we seen in the biological treatments, that is based completely for the young treatment leachate and cost economical. And again, when we are going to the leachate get old after 10 years, of course you have to automatic, because leachate generation will be there maybe 25 to 30 years after even closing the landfill. Also 15 years you close, again 15 more years your leachate generation will be there. So we need to treat this whole kind of leachate. So these techniques can help. Few of the conventional coagulations may include like aluminum sulfate, polyaluminum chloride, ferric chloride and ferric sulfate. So here, based on the previous studies, they have conducted the studies with the chemical use like ferric chloride and the ferric salts, and they are able to remove that 40 to 50%, 53% of COD removed, and 75% and 45% of TOC. However, TOC and COD, it's okay. We can know that organics have been removed, and you can find there is no like 90% removed, or there is not like completely the leachate get treated. However, this can give you a partial treatment. The chemical treatment can be used as a pre-treatment. It cannot be used as a complete treatment. Adsorption. Adsorption is a physical process. It's physical phenomena. It is a surface reaction. It's multicam, which actually what happens when we are using adsorption techniques. Again, precipitation using like calcium hydroxide chemicals. We make the pollution precipitating and correct. This is cost economical, but the efficiency is highly metal. So you can find the chemical precipitation process leachate has been treated, and they have found very limited amount of 27%. Maximum of 50% of COD has been removed. And similar adsorption process, when we are going to higher BOD contest, it can be 90% of removal is achieved. But however, this study based on the country to country, it will vary. Based on the characteristics to characteristics, it will vary. If you want to establish a system in our country, first initially we need to characterize according to our consequence. Treatment fixation can give you a better solution. Like chemical oxidation. Chemical oxidation method is used for treatment of leachate containing refractory compounds. Like AOP, advanced oxidation process, of the recent process for treating leachate. The main attraction is the most advantage. Actually, it do not generate a more sludge like a coagulation. When we use a coagulation treatment process, whatever the flocculated and destabilized material will be settled down. So we will remove the supernatant, then sludge generation will be there. When we comparing to the oxidation, sludge generation is highly oxidation processes. Commonly AOP processes used with oxidation agents like ozone, hydrogen peroxide, and combination of ozone and hydrogen peroxide. Again, we can use irradiation techniques like UV with ultrasonification and microwave. So reverse et al. Has investigated the treatment of ozonation. In 1 hour dosing, 30% COD was removed, and 120 hour 90% of the COD removed. But we have to consider the cost of the ozonation in this case because it is expensive process. If you are giving ozonation for half an hour, it is okay. At 30 minutes or 45 minutes, it is okay, acceptable. These processes are quietly efficient, but the disadvantage of the AOP is high demand of electricity. That's what I told. And for devices like ultrasonicator, ozonizer, UV lamp, it is very high operational cost. But however, certain unavoidable conditions, the wastewater cannot be degraded. We have to use, and bulk usage can reduce the cost as well. And the pre-treatment also avoid the load to the chemical oxidation system. Next, Fenton process. You are aware of Fenton process is nothing but your Fe2 plus ion like ferric sulfate mixed with your hydrogen peroxide. It is nothing but OH radical is generated. OH radical always attack the pollutants which is negatively presented. So it will attack and it will make neutralize and it will get degraded. Actually, performance of photofenton process has been reviewed by many authors. They have did the study. They were able to achieve again 70% COD, 60%. And I suggest that these are the processes cannot directly used for the young leachate because of this cost. Then we need to initially optimize the doses, and one of the good advantage of the advanced oxidation process, the leachate or wastewater can be after the advanced oxidation process, the BOD by COD ratio, it is nothing but biodegradability get increased. So that is good. So we can further use this wastewater for your biological treatment process. Wet oxidation process is a classical techniques. Wet oxidation process is usually used in the industries like vanilla making process, vanilla flavor. It is a high pressure reactor we use the high catalyst. Nowadays, very famous is an nano catalyst like polyaniline, and so this kind of catalyst can be used in the wet oxidation. So the study was done in a laboratory. They use cupric sulfate. It is not a nano catalyst. They use a catalyst. So they did a study, but however, yeah, whenever we comparing to a commercialization or your make a big plant, it will be difficult because it is a high pressure reactor and need a high energy. Again, performance of ozonation. So you can see the ozonation process directly used, and 70% removal and 90% of the COD. And matter is how much time they utilize the ozonation here. Other treatments like and apart from chemical treatments, they are using the reverse osmosis, microfiltration, ultrafiltration. You are aware of that. These are the treatments which we usually use for the drinking water. That means the water is supposed to be used for drinking purpose. We use these techniques. It is also expensive treatments, and when we use for raw leachate, of course the system will get collapsed easily because of more salt present over there. So finally, the summary of various treatment processes. So we can see the combined treatment with domestic sewage, like types of treatment, target pollutants. So combined treatment used for total solids, recycling improve the quality of the landfill and the stabilized leachate. Again, aerobic process like suspended dissolved solid. Anaerobic process will help to remove the suspended and dissolved solids. Like physicochemical treatments, like you can go for coagulation, flocculation, and help to heavy metals, suspended solid, and coagulated solids, as well as your organic matters. The chemical precipitation help to heavy metals to settle down on ammonia, and adsorption like oxidation that directly target to the organic compounds. And membrane filtration, these are expensive treatments if the condition is necessary. Few studies has been research wise done, but it's not commercially done to test the efficiency of the process. Like the microfiltration, they can remove the suspended particles. Again, the ultrafiltration can remove the high molecular weight compounds, sulfate, salt, argon. Whenever the condition is comes that it need to be treated to drinking water standard, then this process can be utilized. Otherwise, it is not an advisor. Okay, now I will go to the. I hope you understand the basic. What are the treatments? You are aware of that already. What are the basic treatments we can classically can be used for the leachate? So now we have collected the landfill leachate from the Mumbai Devnar landfill, which was the landfill started from 1947. It was one of the oldest landfill in India. So we collected the waste leachate, which is 25 years old. So you understand what is 25 years old leachate means. There is no biodegradability. So there is no direct possibility of biological treatment. So we decided we can give a couple of treatment, and we decided this also. Once we cannot change the treatment scheme for every 5 years, maybe we can bypass the wastewater to the some other system according to the. So we decided we can generate a combination of system which can help to treat the Indian leachate, because in treatment of Indian leachate very limited study has been done, because our quality and quantity and characterization of leachate is entirely different, and it has so much high organics and equivalent heavy metals. So what we decided, we collected the leachate and we used this scheme. So we tried like chemical treatment like coagulation, and hydrogen oxidations like hydrogen peroxide, ultrasonication, sodium persulfate, like advanced oxidation like phentan, photophentan ozonation. From among this, we choose what techniques. So that is the primary treatment. Then secondary treatment we decided, so we can go for the secondary treatment. It's like you can tell a pre-treatment. We going for a main treatment is like a oxidation techniques again, and we went to again a biological treatment to meet the standard. So now I will tell this few facts about the Devnar landfill. I told us it is the biggest in Asia. It is oldest 1927. And is already retired. This was already almost retired. There is no more dumping, but still dumping is going on. It is unavoidable. Devnar had outstanding saturation point carbon. This is like currently dumping has been carried 110 hectares and it is already filled. and the leachate was collected from Demra Road, like summer, monsoon and winter. So what we decide, we want to do a study, conduct a study, we want to analyze the characterization and as well as we want to do the treatment. So initially we went and we collected with the permission from the BMC, Bombay Municipal Corporations. We collected around, every time we collected around 350 liters of landfill leachate we used to take. So with this study I have conducted in IIT Bombay. So seasonal variation and characters of landfill leachate, you can see. So interesting things we collected, we completely done the analysis of physicochemical as well as we completely done. So we found again the leachate in summer, monsoon and winter, there is no significant change in the characterization. You can see pH is almost around 8 and all are dark brown color even in the monsoon. And COD values around 2200 and TOC varies in certain conditions like monsoon and winter and other things. Okay, but BOD is same. Again, BOD by COD ratio is very less, particularly in summer is 0.16 and other time is 0.26, 0.2. That means what this leachate indicates that this leachate is directly not, however the age indicates and the result confirm that this leachate is directly not suitable for the treatment by using biological techniques. But of course we need to do a treatment to leachate because this is the open dumping yard. Whatever leachate is generated, it is, I can show in the first picture, whatever you can see, this is the condition. The leachate is generated from the bottom of the landfill. It is going to some nearest pond, so it is directly connected with your groundwater. So we need to collect this leachate and we need to do the treatment. However, they re-innovating the landfill. So you can see the TDS also 9,000 to around TSS. You can see all max except, you can tell except gold. All the elements are present, heavy metals. You can tell because gold is not present. You are aware of that. In Mumbai, like Mumbai, Delhi, Ahmedabad, these kind of cities are. What happened? This waste, whatever waste is generated, first it will go to rack pickers. The metals will be collected and it is sold into the kabadi wala, whoever. And after that, this metal may not be a problem in these landfills because it has a money value. They used to sell that. And remaining like other, you can see heavy metals like sodium, potassium, magnesium, barium, silicon, cobalt, arsenic, selenium, chromium. And you can go in ICP, you put and it gives all the results. We wonder, but a few of them are maybe below detectable like mercury and bismuth. These are all not there. In some cases, silver we found. So we decided, so there is no significant changes in the characteristics. That means the old landfill leachate may not be affected by any seasonal changes until it's directly diluted with your rainwater. If the open dump is there, the rainwater is directly diluted. And we found in very few interesting studies, even dilution cannot help to the treatment because that complex organic compounds are present. Dilution is not the solution. Again, they are doing a 1:50 time dilution, 100 time dilutions. The Renovatal study has been conducted in Malaysia, Penang landfill. They conducted study. They did up to 1,000 times dilution, sorry, 100 time dilution. They did the wastewater by biological. It's failed. So we decided we want to conduct the coagulation study. So initially, which pre-treatment we decided based on the possibility of the literature survey I have showed, we decided the coagulation study can be conducted with various commercially available coagulants. So what we decided, instead of going analytical grade chemicals, we collected the coagulants from the commercial stores, like commercially available for the treatment plants. So what are the coagulants we collected? We have collected some 9 coagulants like ferric sulfate. I will show one by one. These are the jar apparatus we used to optimize the study. You are aware of that coagulation reaction takes place at certain pH and certain dose, like optimum pH and optimum dose. The leachate is collected and we kept it for 1 hour to attain room temperature. After that, in the 500 ml beaker and at a 500 sample, and we vary the pH from 2, 4, 6, 8, 10, 12 by adjusting using NaOH and HCl, 5 like 1 molar. And again, addition of coagulant, we added a coagulant standard and rapid mixing for 5 minutes and slow mixing for 3 minutes. You are aware of that first initial 5 minutes is the chemical mixing. The wastewater or leachate which is mixed with the coagulant, and after 5 minutes it will be 30 minutes for your flocculation time. Then after that we allow to settle 1 to 8 hours. We collected the supernatant and we have analyzed the pH, COD, TOC, turbidity and color. And we have tested with the ferric sulfate and we have found again 48% of removal achieved, COD removal, and 53% of TOC removal. Turbidity and color. In turbidity, excellent removal has been achieved most of the coagulants except few, and color removal 61%. And the coagulant use initial, actually there is you can tell optimum coagulant dose was like pH 6 and coagulant dose at 6 milligram per liter achieved. You are aware if overdose of coagulant into the when your optimization of pH study done, if you are adding continuous coagulant to the your leachate or wastewater, so what will happen? It again the destabilization will take place, so it will disturb the settlings. I hope you are aware of this. Again, ferric chloride. Ferric chloride is one of the commercial coagulant is available used in the many industry. We found the pH again pH 6 as optimal pH, and we are able to remove 63.4% of COD. We used ferrous sulfate. You can see the picture here. So how you can compare how the color removed, and again we used a ferrous sulfate, and we were able to remove on 41%. Again we used an alum. Alum used to help us to remove again 43% of COD. We did complete coagulation study, and we found again the potash alum we used. Again we found again 6 milligram per liter of coagulant and 6 pH at 6 milligram per liter of coagulant. We used PAC, polyaluminum chloride. Interestingly, we found that I will share the result calcium hydroxide, calcium chloride. So this is our significance of treatment. You can see here. So based on the color, we cannot judge it, but however we can guess it. So which can give them maybe a better efficiency. From here, I can tell you. So we found 63.4% of polyaluminum chloride. You may be asking, sir, even ferric chloride is having the 63.4%. Why you chosen this? Why we chosen this? Because the handling of polyaluminum chloride is highly easy comparatively ferric chloride, and the sludge land generation is very high in the ferric chloride along with this, and little bit colorant of the solution. And comparatively here, it is the color removal efficiency also very high in polyaluminum. Overall, we decided polyaluminum chloride is a better coagulant which we used in the study. Among the 9, the PAC is the good one. So now we decided 63.4%. If you are aware of the 2000 is there, the 2000 COD is there, 63.4% is removed, around 60% is removed. It is nothing but it will remain again a 800 COD in the system. It is not a complete treatment. So further we decided, so what are the next scheme we can proceed. Actually, we have done a double coagulation also. After coagulation, the supernatant was collected and it has been again treated with the coagulant, but of course it doesn't help anything because it's overdosage only. Just as a trial run we have tried, but it's not successful. However, we tried various oxidation studies. Initially, we want to know that a direct oxidation can benefit for the leachate, or a combination of a coagulation oxidation can help for the leachate. So we said that initially these are the oxidation techniques. So we used simply used this in a beaker. So we added a mix in a beaker with a stirrer. We added optimized the dose with the pH varied from 2 to 4.5. So you may be asking why this 2 to 4 from the most of the literature. You come to know that actually. So this kind of oxidants working particularly in the acidic ranges. So this is the optimal ranges. So we tried within the ranges. We found at pH 3 at the optimum dose of 6 gram per liter, we were able to remove around 39% of COC. After this, we studied with the TOC because because of TOC, we have a TOC analyzer. We can get a fast results as well as we can compare with the trend was same. So finally we compare with the COD. However, we found the organic removal like 39%. So again we tried the sodium sulfate. Again the COD removal was 40%. And we tried, we can ultrasonication. It is a basically ultrasonication is also a kind of advanced oxidation process. It induce your it will generate your OH radicals. So we tried with the hydrogen peroxide. Will it generate really? But it doesn't help. You can see it doesn't help. 39% removed is more, 3% is removed using your ultrasonication. So that also doesn't help in this case. You maybe see most of the pentachlorophenol and phenolic studies, ultrasonication played a major role, which generate so much OH radicals. But when we are coming into the leachate comparatively wastewater, particularly because what happened, there are monopollutants, which is a targeted pollutants, which generate a synthetic wastewater. Like we add 1,000 ppm and we given some treatment. So our initially our aim and target was fixed. We should not use that synthetic wastewater, because most of the studies you have seen, I have shown in the literature, most of the studies they diluted with 50% are synthetic wastewater, because unless it is not possible. So we want to try a raw wastewater. It's untreated, undiluted wastewater, real wastewater we want to treat. We were clear about that. So we have did this study and it was not given maximum removal. So oxidation study doesn't help. So we tried advanced oxidation study. It's basically advanced oxidation study. You can see we used few studies like Fenton process. Fenton is nothing but in presence of catalytic oxidations, we use a hydrogen peroxide along with a certain optimal pH. In these studies also, we need to initially first, that is common procedure I am showing you this. Optimize pH, addition of dose, optimize dose, optimization of H2O2, optimization of FeSO4. In you are going to, in the case of coagulation, optimization of pH, optimization of coagulant dose. Here more than 2 chemicals we are using, so we need to optimization of H2O2 as well as optimization of ferrous sulfate. So we decided, so we did this study, we found major significance, there is no optimum removal achieved, and however we found 55% of the removal achieved, and optimum pH like initial optimum pH around 4.5. So we have found, and at the 4.5 we are able to receive again 55% of your TOC removal. Again effect, this is effect on pH, and we have seen effect of dose. You can see the trend, there is no much changes, but however initial dose itself we are able to get about, so we kept initial dose itself optimal dose 56 milligram per liter, 56% of TOC removed. Again Fe2 concentrations, we have added like 100 mg of Fe2 to 60 mg, it's a molecular, and again we are able to receive 60%. So we are able to receive, from this conclusion we are able to receive about 60% of these techniques. So next we have planned, okay, now this, however your coagulation gives 64%, your Fenton gives advanced oxidation given again, you can say 58%, like 55%. Again, if you are going with another technique, we will try, maybe we can give a try on a photocatalytic reaction. We have photocatalytic reaction proven techniques. UV catalytic reaction will be there. We designed our this own reactor ourselves. So this is a quartz based reactor, and actually you can see here, this is the UV lamp which is inserted. This is a jacketed wall with the cooling water. This is circulation to avoid temperature, because the reaction supposed to be takes place, the UV radical supposed to be created by the temperature should not increase during the reaction. That is the main. So we use a cooling reactor in this, and we have a sampling port here, and we have a temperature sensor to monitor, and we find the Fenton process similar like Fenton process. It's considered in the photocatalytic reaction in a reactor. So we found again in the photo effect of pH, we found optimum pH was 2.5 and this TOC removal of 555. Again we found optimum pH was, optimum dose was 1 gram per liter, and the TOC removal of 55%, a varying dose. and optimum dose of Fe was 500 mg and TOC was 65. So next, so here also you can see the 65% is removed. Comparatively, coagulation is 1.5% efficiency is removed. Again, when we go to ozonation experiment, so we tried a ozonation also. Okay, we can try a ozonation for this. Everything tried for the treatment done for untreated leachate. So we have tried a ozonation. This is basically the oxygen generated nowadays due to COVID activities was very famous. When we do study those, not that much famous. This is basically oxygen concentrator. It create a pure oxygen. Then we convert, we will send it into the ozone generator. Due to corona discharge method, it will convert oxygen into ozone. Then we will put it in the reactor. So we put it in the reactor. This is for escaping, to collect the escaped ozons for 2% of potassium iodide. So during this reaction, we also optimize the pH. So the pH is varied from again 2 to 10. And we have found the optimum pH was 10, and we have to able to remove up to 45% of TOC. Again, the dose, we vary the dose and 5 gram per hour and 48%. And wonderful things, we used only for actually 20 minutes. This entire reaction takes place only 20 minutes. The flow rate was fixed. We are not used for longer duration because that is not a feasible in a commercial base or in a technical base also. So we don't want to do in longer duration. However, we used for 20 minutes. This time after this, we have whatever study. So you can see what are the main summary you can find here. So which is the efficient in this along this all oxidation study in hydrogen peroxide found 6 gram per liter, and color removal again TOC 39, 42, 60, 65. We found photofentan is really efficient because it is 65% of removal is occurred comparatively your direct fentan. So we decided, and the dose usage you can see, and for hydrogen peroxide is all significantly reduced again. So we decided this is a good optimum techniques for RTC. And but however, if you want to use as a pre-treatment, we can use for coagulation or photofentan. So we always suggest we cannot go for photofentan because it need energy to use this reaction. But we can, however, we can go for a coagulation. It doesn't need much energy comparatively, except mixing. So what happened? We plan now. So we have already done the pre-treatment and main treatment, and we found okay, we will go for a combination of treatment. So we decided the coagulation is now the fixed as a primary treatment, like preliminary pre-treatment, and followed by whatever your oxidation, advanced oxidation techniques are there. We have tried with this key coagulation followed by UV with H2O2, and we have found TOC removal of 64%. And when the dose was optimized, the 4 milligram per liter, we have found TOC removal of 69%. Again, we have found again TOC removal of 74% at optimum. This is nothing but coagulation with photofentan, coagulation with fentan, and coagulation with UeH2O2, coagulation with photofentan. That means coagulation followed by what we used to do. We used to take a huge number of leachate, like 10 liter. We treat it. From there, we collect the supernatant. We further used for the photofentan techniques and whatever the techniques, like the effect of your hydrogen peroxide dose. We found again 74% of it's quite impressive. We found first time again the TOC removal is more than 60%. It is 74% removed. Again optimize the dose of ion concentration. We find 75%. Similar, we tried for the coagulation followed by ozonation techniques. So coagulation, we tried the ozonation at optimal pH 6. We are able to reach 66%, and optimal pH 6 and the dose of 4.5 gram per hour. So we are able to remove 67% of TOC. So this was not quite impressive. We have got only 3% removal because coagulation itself 64%. We got more 3%. Similar study we have done, like coagulation plus ozonation plus hydrogen peroxide is. So this is nothing but a catalytic ozonation. It's in percent of ozone, we have tried with the we have tried a accident like a hydrogen peroxide. This is 2 oxygen, it's double dose. So we have found 74% of TOC removal. Again, we have found 76% of TOC removal when the optimum dose of varied, and we found 5 gram per hour is the optimum dose. Similarly, like effect of hydrogen peroxide, we achieved 80%. This is the first achievement. We got more than 70%. This is the 80%. That means the ozone plus catalyst have some impact on the leaching, because the ozone plus catalyst give you a better removal. You can see here. See, what is the main summary of the combined study? Every treatment, initial pre-treatment as used as a coagulation, followed by a main treatment, that is nothing but UeH2O2, which given 69% TOC removal. Again, coagulation photopendan given 78% removal. Again, coagulation plus oxidation given 80% removal. So we decided from there, this is one of the good techniques to remove this one. But however, we were not able to achieve that. So 80% still you have 400 COD in your wastewater. So we're not happy. So we want to try a new scheme. So we plan for this SBR process, a sequencing batch. This is one of the most common technique nowadays used in the sewage treatment plants. This is nothing but your activated sludge process in a batch mode. So if you use activated sludge process in a batch mode, like these reactors operate at every 6 hours or maybe every 8 hours. 8 hours means you need 3 into 8, 24 hours. That means 3 tank you need if you are operating by 4 batches, you need a 6 hours. If 6 hours means 6 into 4, 24 hours. That means one tank first reaction is takes place, another tank, another output will come. That means continuously your input equal to some output plus accumulation, however come, some output will come. Whenever wastewater enter inside, the wastewater go out. So here, by varying the volume, we fix the HRT. So we initially, you are aware of that biological study, we need to fix the HRT and SRT. So we tried the parameter 1.5 days HRT, 2 days and 2.5. This is varying by volume. However, the batch was around 12 hours only. Our batch is 12 hours. Every 12 hours, we collect the samples. We treated the leachate and we collected. The replacement volume of the sample, you can see 333 for 1.5 HRT retention time, again 250 and 200 millimeter. Similar. So what I faced whenever I was very happy with the chemical treatments, I got up to 80% removal. So we were very happy, but commercially it's viable or not, just research purpose we did, but it was working very. So again we tried like 3 times its rejections, because the leachate doesn't have any microorganism. It is already it is not ready to adjust with the sludge we collected from the domestic sewage treatment plant. So we decided after doing a lot of study, we found that so it's need acclimatization. So we need to acclimatize the leachate as well as we need to acclimatize the sludge. So what we decided initially, loop full of raw leachate sample was inoculated. We inoculated in a nutrient broth, incubated at 37 degree 24 hours. The fully grown, like we are increased from 30, 35, 40, 45, like we increase up to 95%. So the broth incubated 37 hours. So this is nothing but, so up to sequentially we need to take a culture and we add a leachate. So we like 95% of culture will be there. We add a 5 ml of leachate. Like again 95% will be reduced of culture will be reduced into 90%. Leachate concentration significantly is in 10%, 20%, 30%, and we need to grow up in the reactor. It's not a day process. It will take a 3 months to grow up again. It meanwhile failure, then you have to repeat the same. So we grown up for 3 months around. This is successfully grown up to 95%. it adapting with the broth. So we decided now we need to acclimatization the sludge. So in a SBR reactor, 600 ml of sludge plus 100 ml of acclimatized mixed consortia, whatever I told from the initial one, we taken 100 ml and 300 ml of pre-treated coagulated leachates. We are not taken the 81, we want to treat from the pre-treatment. So we using a biological treatment as a main treatment now, coagulation followed by biology. After 24 hours, 200 ml supernatant water removed and replaced with a new pre-treated leachate. Nothing but a coagulated treated leachate we added, and pH was corrected to 7 because it was supposed to be natural. So it was aerated 1 liter per minute, continuous up to 20 days. So we have done this study. We followed from here. I just done the study. So we have followed the study. Further settling sludge was collected, mixed up. So what happened after 3 months? Again, this 3-month study, 6 months, it has accepted. Our leachate is accepted to stabilize with the microbes. We had stored this culture in the refrigerator. If any time it fails, we can re-inoculate it. So we have did this study, and we have collected the sludge from the wastewater treatment plant, STP plant. And these are the characteristics of the sludge. So you can find TS is 33,000, again 2.9 gram per liter to suspended solid, volatile solid is 1.2, and COD is 9,200, 300. So we have done a 72 hours batch study. So we have done the batch study, but what happened initially, you can see over here. After 12 hours, we found again there is a drop of, there is no improvement in the COD removal. However, there is an improvement up to this much. So 86.7% is removed. But here, why it is a drop is there? That means this is not accepting, that leachate is not accepting in the system. So we decided we can, this is the batch study. We decided 12 hours is okay. So after 12 hours, we don't want to continue. Every 12 hours, we plan to treat with the new leachate. That is the cycle. So we did with the SBR study for HRT 1.5 days, and we were able to remove. You can see influent TOC is 340 milligram per liter. Effluent is 214. Again, it's get treated. Again 1.5. Again, we can find around 76.9% of your TOC has been removed. Next, for HRT 2 days, we are able to remove 76.5, and HRT 2.5 days, we are able to remove 79%. So we thought, okay, HRT 2.5 is the optimum dose. So we decided to do the SRT study. So we did the SRT studies for 2.5 days. So 2.5 days SRT studies, we were able to remove around 83%. It significantly increased. Again, the TOC, again we have done for 5 days SRT, it is 79%. And we have done for 7.5 days SRT, so it is 78%. So we decided 2.5 days HRT and 2.5 days SRT is the optimum configuration to run this SBR process. But we found after every 12 hours, there is a drop, there is no degradation continuation. That means whenever you are adding a fresh leachate, it's not, that means the treatment is not, the deficiency is not increasing more than 80%. So we decided every, instead of this one, every 12 hours, we will replace the leachate, new leachate, we will treat the new leachate, and every 72 hours, like every 3 days, we used to remove the biomass renovation. Because what happens, this biomass renovation can enrich the study, it can also increase the removal efficiency. In a mixed reactor, 1/3 of the wastewater we collected, the leachate whatever the entire section we collected, we put the new fresh sludge, acclimatized sludge we transfer. So what happened, this condition every 3 days we used to do 72 hours. Again we found again 84% of removal. That means biomass renovation really helped to achieve 84% of TOC removal. So next we decided, so okay, still we need more because 84 we received. So my target was around 90, so we were trying some other techniques to achieve that. We did a lot of literature, so we found that selector zone with SBR. This is the new techniques that we were used. This is the selector zone. This is the commercial type of SBR. We found a selector zone. Selector zone is nothing but this is the zone which specially inserted before into the reactor. That means before filling the wastewater directly filling into the selector zone. It will stay up to 30 minutes. After that, it will transfer to the. So there is no time takes. Like what happened whenever we did the study, we had made there is no mechanical mixing. This is the mixing which is given every 8 hours for 30 minutes to avoid any such settlement. So in this zone, what happened? This is basically a aerobic plus anaerobic zone. It's anoxic zone. So we keep the wastewater there for particular duration throughout the like 12 hours we keep it. So what will happen? Whatever the wastewater presented there, they start they start hungry. They feel microbes head are starving. So they start consuming the nutrients like ammonia, nitrogen, and phosphorus load. So they start consuming this. So ultimately, what happens? The load to the main reactors get reduced by the selector zone. That is the beauty of selector zone. The main load to the reactor get reduced. So in this case, we tried with this study. So we have done, and we found a maximum, and we found an yes surprising result again. 87% of organics TOC was removed, and we have optimized again this study. Again, we found 90% of that removed 4.5 to 9 days. So we can find the summary of coagulation. You can see the completion of the study. We found SBR with biomass. SBR is given 80%. SBR with biomass. This is followed by coagulation. Is giving 84%. FGR with selector zone given 87%. This combination of the biomass renovation with the selector zone given 91%. So finally, we are able to achieve that 91.5% of with using biomass renovation techniques. So you can see that characteristics of leachate at the various different states. You can find here is untreated leachate. It's 340, 890. This is after coagulations, the concentration TOC, and you can find that this is around 245 and 105 degree. So we completely removed the stage, and after that, actually, we decided for a coagulation. The time was there. We decided for ozonation techniques to remove further. So this is the summary. So we found and optimized. I already discussed with that the main study was done. The SBR with the selector zone was assessed, and we renovated with 2.5 days with SRT and 2.5 days with HRT. The maximum removal of 91% TOC has been removed. 91 color was achieved. This source selector zone was necessary for getting consistent bioreactor performance for maximum TOC. Among the all bioreactor study were for SBR with the selector zone and biomass renovation is the good followed. Before that, we need to do a coagulation study. So this was given an overall picture how this the treatment takes place for the landfill leachate. So we have done this study. We have published around 20 papers in this work. So we have presented in many countries like Singapore, Hong Kong, Sweden. So if time permits, I will tell about very few minutes in the other study, which we have done the same landfill leachate treatment we have done in the study in the Sweden. And interestingly, we found when we go there to the landfill doesn't look like landfill. It look like you can see there. This is landfill. Whatever area I am noticing, this is landfill. It is closed. You can see there is a grass over there. So this is the landfill. This is the leachate collection system. See, we found the leachate is highly clear. There is no issue of BOD, COD. They are very far away. They are only facing the problem of nutrients like ammonia, phosphorus. They are facing only nutrients issue. They are not facing with the biological loading or organic loadings. Because the landfill is well designed and the leachate collection system is proper. And what they are doing, they are not doing any treatment this leachate. They are directly connected with the sewer line because the characteristics of the leachate is similar like your sewage. It's less than your sewage quality. But however, some heavy metals were present. It's a trace level. It's not. It is a PBB level. So what we decided, so we want to do the study. You can see the plant, how it's beautiful. This is the landfill. You can see over there. This is the landfill. This is the leachate collection plant. Perforated pipes will be there. They collected here. So we collected leachate. So the samples were collected. So what we decided, there was a leachate treatment can be done by a biological method to remove the nutrients present in the wastewater like ammonia, nitrate, phosphorus. You can see these are the characteristics of leachate. So there is a pH, nitrate, nitrogen, ammonia, total phosphorus, and you are aware of that Europe that you cannot do COD, you can do only TOC. So there is no much in that. So what we decided, we plan to mix the lake water with the leachate. Lake water, this is the frozen lake. It was -20. We collected the frozen waste lake water and mixed with the leachate. We trying to grow a microalgae over there. It is nothing but microbial cultivation, microalgae cultivation in the wastewater to nutrient removal. This basically we collected and we put it in the incubation room. We mixed with the ratio like 100% lake water and we changed the ratio 70%, 30%. We see any growth is there. So we found a significant growth over there, and you can see here. And we analyzed also the nutrients. You can see lake water, and then you can see this water, and we have what 0 day we did for 20 days this study, and sample 2 and sample 4 having maximum role of ammonical nitrogen. That means that ammonical nitrogen has been removed because it was consumed by the algae which is grown. That is a mixed culture. Basically, it is dominated by the Chlorella vulgaris. So we have done the study, lake water mixing with the your leachate. We were able to remove a significant ammonia concentration and nitrate concentration as well as the phosphorus concentration. You can see, as well as few heavy metals also absorbed by the microalgae. You can see the heavy metal. So few heavy metal concentration also absorbed by the microalgae. This is, you can see. This is initial days. This is before treatment. This is after treatment. Few cases even zinc and these are all absorbed by the microalgae. Nickel. In cultivation after 12 days, noticeable growth was found. All the mixes as expected. There was more good samples were added. Was lake water because the lake water mixed with the leachate has given more growth as well as more. So again we decided, so this algae is growing. So what we did, okay, the leachates are treated and we mixed with the lake water, some growth is there. Ultimately what we can do with that? So we decided, so to grow a microalgae in a wastewater leachate, particularly this is mentioning wastewater plus leachate is mixed. So we grow in a big fish tank. So you can see here, we tried a BMP experiment. So how this is helping in the anaerobic digestion? We tried whatever algal grow because it contain high lipid content. It helps to the anaerobic digestion. What we did, we grow a algae in a bigger level. We grow in a bigger tank, like 125-liter tank. We collected the algae by weight, so 12%, 25%, 35%, algae 37%. We mixed with our raw sludge along with our leachate and the wastewater. We tried, and significantly we found 12% of algae can increase the production of the biogas in the anaerobic digestion. It is as well as treating. It is also producing a more biogas comparatively the raw sludge. Raw sludge even unable to grow that much gas. That means addition of microalgae into the anaerobic digestion help to increase the biogas generation. We found this, and we have also suggested to the municipal corporation of the Mälardalen, where is the Sweden. So they in their wastewater treatment plan, they implemented in a pilot study. So I have completed my term and I came. Then after that, I have curious to know that what will happen to the landfill cover. India, we have a landfill cover. After 10 years, what will happen? Most of them we were not much aware, but we were aware. I hope so. But what will happen to the landfill cover? So we got a study there. So the landfill, now landfill leachate collected, treated, landfill is covered with the soil layer, sewage layer, cover layer, top layer, everything finished. Then this is the grass started growing. So that they approached one company has approached us. This they want to give for the grazing for the lamb or goats, whatever the animal grazing they want to give the landfill. They can eat the grass which are growing over there, but they want to conduct the study. So I have conducted the leachability study. So we we collected significantly leachate. So what we did a leachability study. So the study was conducted, soil 1, 2, 3 added with your significant amount of water, and we put it in the your orbital shaker. So what we did with this complete this study, and we found whatever the sample we collected in the soil which contain cadmium, nickel, again copper, arsenic, zinc. This was found in the soil whichever in the top cover. That means heavy metal possibility is there in the soil. So this cannot be allowed for the fodder. So they cannot use this. You can see there. Cadmium, copper, arsenic, zinc, so many metals were already there in this. Actually, apart from this study also we have done, we cut the grass and we dried it, we done the heavy metal analysis. After that I came to know that even the grass which is grown that contain heavy metals, that means it take the heavy metals from your soil. Thank you. Yes, sir.
Yeah, thank you, Dr. Shabima.
Thank
You
you.
have
Thank
given
you.
very much insight into leachate treatment and how that is done in India and abroad, and how difficult it is to be done in India, because of the complexity of solid waste dumping and other things. So I ask participant, you can ask the question. Uh, you can write in the chat box also, or you can directly ask. Uh, let's go.
Sir, one question, sir.
Yes.
Yes, please, sir.
Sir, during this leachate treatment, what is the quantity of sludge formed, sir?
Sir, it depends on the treatment we use, sir. Actually, it's you aware of that leachate. Actually, whenever we collect the leachate, it usually contain lot of soil because it is from the bottom. You must allow to settle it. If you are allowing to settle, maybe around 30% of the during coagulation process. This is unavoidable.
And what process we are going to use for this further disposal of this sludge?
Sludge we need to safely dispose, sir, because it contain heavy metals. Because sludge disposal again a big task, because it contains heavy metals. We need to go for engineering landfill. We may be putting with the cover, along with the landfill cover we can use it. So that will, because if you are using a safe landfill, we may having a liner system which will not allow the our leachate penetrate into the water. That there you can use it, or either it's organic sludge you can burn it. But however, when you are aware of that heavy metal which is present in that may be leaching into any environment. So we need to do a safe engineering landfill disposal.
Okay, sir. Sir, these landfills are around sugar industry,
Yes, sir.
where the CODs are in the range of almost in lakhs.
Yeah. Actually, so even I'm not supposed to answer in front of Dr. Sanjay Singh sir because of distillery, because he has done a PhD in distillery wastewater. He dedicatedly spent so many years in the distillery wastewater treatment. Because distillery wastewater usually have a huge BOD CODs, even in lakhs, 2 lakhs. Till what they usually do, they do anaerobic treatment and they take it into 50,000 milligram per liter. And after that, the study will be done. Actually, Dr. Sanjay Singh sir has done a
Yes.
very
Yes.
efficient
Yes.
study.
Yes, what is done in the distillery, if there is a land application to the whatever the distillery effluent is there, then there are chances that due to the landfill application and due to the nutrients, they are doing the land application on the agricultural land. So there are the chances that some recalcitrant organic compounds they found the way into the groundwater. So we have to be very careful in that way.
Actually, in India, that is the practice. Actually, in the monsoon season, they're removing the distillery wastewater, which is stored in the tank lagoons. So they're removing with the monsoon may be diluted, but if directly you dispose this into the land, this you will get a sickness. The land gets sickness usually. The land become infertile soon.
Yes, yes.
Sir, have you studied on something on this thing? Fisheries water, fisheries industries, the wastewater they generate, they are having
Yes.
a COD, which is very difficult to bring down.
No, no, even biological treatment will do, sir. Fisheries, we have studied that actually. We have done in the Mangalore, we have done the fishery studies. But fishery treatment wastewater is not a problem, but it contains lipids and the fats. That is the problem actually.
Yeah, correct, sir. Because that is
It
why it is very
because
great.
yeah, it is contain the lipid and this one. So you maybe use a little vigorous treatment to do that, as well as we need to remove the oil and grease removal. Like if you are done advanced oxidation process, of course oil and grease will give a disturbance for you. So initially
Yeah,
trap wise we need to remove this suspended materials, then followed by we can do a treatment. See, of course lipid and this one will be usually float. It won't, this fats everything will be float. A proper sedimentation or proper coagulation reaction takes place, then particles are removed or flotation techniques, then this wastewater can be treated directly to the biological treatment. This will be helpful to the microbes to grow even.
yes.
Sir, uh, am I audible to you?
Yes, please.
Sir, can you highlight that how to tackle the leachate which is generated from TFDS sites? Because it is a real headache since Gujarat is highly industrialized state.
Yeah.
This is the problem either which is faced by industry directly, those who have their own TSDF sites, or it is a common TSDF site.
Actually, I understand what, but partially I understand. What do you need to be exactly? Can you repeat, please?
Sir, it is a total secure landfill sites where
Yes,
all the waste that is dumped is supposed to be hazardous waste. But
yeah. That is
leachate
hazardous
is
waste. Yeah,
generated always. And
yeah.
since we are a highly industrialized state, this is the issue which is faced by each industrial estate almost.
Actually, whenever hazardous, that you aware of that hazardous waste rule
Yeah,
2016, whenever
yeah.
we generate a new hazardous landfill, that leachate treatment must be there. And hazardous waste landfill will not usually generate a huge quantity of leachate, madam. You are aware of that. It
Sir,
is not like,
no. Practically, I don't think so because we had one case. I don't want to name it, but
okay, sir.
actually, moisture content was very high, and
Yeah.
there was a damage to the earthenments, sidewalls, and lot of spillage was there, sir.
Okay.
In real life, it is a problem. Theoretically, may not be.
No, I'm telling this is actually as per the rule they supposed to treat with the your physical chemical treatment. At worst case, they can do incinerate it actually. Along with this wastewater, they have to do evaporation. Then whatever the moisture is removed, after whatever the portion is there, they need to incinerate because it not only contain heavy metals, it also contain so many what you can tell toxic compounds over there.
Yeah,
So they need to be incinerated, they need to capture it, neutralize, because otherwise it will release dioxin like materials into the atmosphere. That is also highly dangerous. They need
but
to,
sir, if priority pollutants are present in it, is it advisable to incinerate it?
no, because we cannot do this particularly hazardous landfill leachate as a treatment like our conventional treatment methods. That is the problem.
That's why
That's what
any
whatever we best level we can do. We have to remove the moisture by evaporation because evaporation will not allow you to take the pollutant. You are aware of that. Whatever concentrated material is there, that can be secure landfill or even it has to be incinerated. Matlab, this has to be incinerate kind of things.
okay, that is the only final solution, right?
Yeah, that is the currently we are having that much options only with us.
Okay, thank you very much, sir.
In future, thank you.
Okay, one question is from Suchitra Rajput Chauhan.
Yes, sir.
What is your input on whether to focus more on waste management or to focus on treatment process?
See, we need to focus on waste management as well as we need to do the treatment process because we have so much landfills are in India, which is what you can tell, which don't have a proper leachate collection system, which treatment system also. However, nowadays, whatever the government of India, whichever the landfill is generated, that is a engineering-based landfill, plant-based, whatever their proper leachate collection systems, everything is there. But we need to focus on both area, because after some years ago, this problem may be faced by the old landfills actually. So we need to concentrate waste management as well and the leachate. And however, there is a valid point. If you reduce the waste, your leachate generation will be, of course, significantly reduced.
I think
Yes, yes.
Okay, any other question? Yes, you go ahead, Shabi.
Yes.
Okay, so if there's no questions, then we can end this session. Thank you very much, Professor Shabi Imam. You have come on our invitation and given a very good lecture and on leachate treatment, because it is a very important field nowadays because of the solid waste dumping here and there, and very much problematic also. Thank you again.
Thank you, Dr. Sanjay Singh sir. Thanks for inviting me, and thank for all the participants to listening very nicely. So I would like to thank to the civil engineering department and HODs and the management. Thank you very much for the providing opportunity. Thank you, sir.
Okay, participants. Yes, okay, participants. So this was our last session, third session. We will be meeting tomorrow for the next session. That is second day, first session at 10:30 a.m. So all will be should be there, and please listen to all the lectures and be benefited from that. Thank you.
All the participants, please log in, join with the, I have created link for tomorrow lecture also. So please join for the day 2 session. Please don't join with day 1. Again, today the several participants have made a mistake that they have joined with mock meeting. But please, now onwards join. I have created link for each and every day, individual day. So please join with tomorrow's link only. Please don't use today's link. Am I audible, all of you, sir? Am I audible?
Yes, you are audible. I think everyone has.
For day 2 lecture, day 2 all the sessions. So please join with that. I'm not going to delete today's link because we have to download few recorded session. That's why I'm not going to delete today's session. I will delete it tomorrow after taking the backups. But please join with tomorrow's link only. Day 2. I have mentioned the day 2. All of you. This is just remarks. Thank you very much.
Okay,
So I have one doubt, sir. The links will be available in the calendar, no?
Yes. Link is available in the calendar.
Calendar we have to join with the link. Okay.
Yes, you can see
Sure.
it is available right now.
Yes, sir.
So today we have any feedback link for the first session?
No, feedback link will be, I think, activated in your account, that is participant account.
Okay.
On the last day. So on that day you have to fill up that feedback.
Okay, thank you, sir. Thank you. So now I can left the meeting, sir?
Yes. So all of you can left the meeting and tomorrow you will.
Okay, thank you for